All right, so we are going to look at the homework assignment. So this is lesson 7, day 1 worksheet. We are going to be looking at number 4, and it says that a 107-foot tall building cast a shadow. So let's go ahead and draw our building. That doesn't look like a good building. Okay, so we have our building, and it says that it is 107 feet tall. Okay, it also says that it casts a shadow, let's just call that our shadow, of 90 feet. I want to know to the nearest whole degree, what is the angle of elevation to the sun? So if the sun is over here, it's kind of going to be in line with the top of that building. So what's that angle of elevation here? So we are trying to find x. So what I like to do personally is I like to kind of pull out that triangle that I've created. And that triangle I'm talking about is this triangle here. So I like to pull that triangle out. And I'm going to go ahead and I'm going to label that triangle. So I have 107, I have 90, and I have x. Okay, and I have that 90-degree triangle. So if I'm looking at this, I'm going to be using trig in order to find that missing angle measurement. So I need to figure out, in order to use trig, I need to figure out what 107 and what 90 is in relationship to that angle x. So 107 is going to be my opposite side, and 90 is going to be my adjacent side. Since I have opposite and adjacent, I'm going to be using tangent. So I'm going to say the tangent of x is equal to, opposite over adjacent. Now, anytime we're trying to find an angle measure like this, we have to use what we call the inverse function. So we're going to say the inverse tangent of 107 over 90. And let's go ahead and let's pull up our Desmos here. So we're going to say the inverse tangent, go back to the main, of 107, over 90. And that's going to give me 49.9. So if I get 49.9, I want to know what that is to the nearest degree and which one that's going to be as far as my A, B, or C. So if I round that to the nearest degree, it is going to be 50, which would be answer C. All right, let's go ahead and look at number 5. Again, please make sure that you're showing work. If you are not showing work and you're just telling me answer C, you're not going to get full credit. Okay. So, with number 5, it said a kite is on a 100-foot string and it has an angle of elevation of 18 degrees. So if I have a kite flying, okay, and its angle of elevation, so from the ground to the string here, is 18 degrees. The hand holding the string is 4 feet from the ground. Okay, how high above the ground is the kite? So not only do we want to find this right here, but we're going to have to add that 4 in at the end. So we have a triangle. We have 18 degrees here, And this string for that kite is 100 feet. So we have 100 here. We need to find how high that kite is above the ground. So we're finding this measurement, X. So let's go ahead and use trig to find that X. The first thing you need to do is make sure we know what sides we have. So in relationship to this 18-degree angle, we have our opposite side and we have our hypotenuse. So with opposite and hypotenuse, we're going to be using sine. So we have the sine of 18 is equal to our opposite over our hypotenuse. Anytime you're finding like a side length of your triangle, you're going to go ahead and you're going to cross multiply. So we get x times 1 is x. And then, then we have 100 times the sine of 18. Okay, the only thing that we have left to do here is go ahead and put that into our calculator. So we're going to take 100, maybe, there we go, times the sine of 18 in that parenthesis. So we get 30.901. Whenever we do that. Okay, now that is this distance here, but we still have 4 down here that we need to add. So we have 30.901 and we have 4. So I'm going to go ahead and add 4 to that, which gives me x is equal to 34.901. And that's going to be closest to 35 feet. So that's going to be answer B. Okay. Let's go ahead and move on to number 6. Okay, so with number 6, it says a meteorologist measures the angle of elevation of a weather balloon as 41 degrees. So we have a weather balloon. Actually, let's make that look pretty. Okay, and it says the angle of elevation. So that's going to be, like, this is going to be our ground. This angle here of elevation is going to be 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from its location. So if this is our radio, okay, it is 1,503 meters from that radio. To the nearest meter, how high above the ground is the balloon? So we want to know how tall or how high in the sky that balloon is. So we have our triangle. We have X. We have our angle 41. And we have the 1,503. Okay, so we need to focus on what sides we're given. So in relationship to this 41-degree angle, we have the opposite side and we have our hypotenuse. So if we have opposite and hypotenuse, we are using sine. So we're going to say the sine of angle 41 is equal to our opposite over our hypotenuse. Okay, again, I'm just going to cross multiply. So I have x times 1 is x. And then I have 1,503 times the sine of 41. Okay, I'm going to pull up my calculator. 1,503 times the sine of 41. And that gives me 986.056. Okay, and that keeps going. But we are actually going to round to the nearest meter because that's what it tells us to do in the directions. So to the nearest meter, we are going to be 986 meters high. So we have 986 meters. Okay, let's jump down here to number 7. It says, Miguel looks out from the crown of the Statue of Liberty. Okay, so I'm just gonna draw a stick Statue of Liberty. Gotta have the little torch. Okay. So we have a Statue of Liberty and we have our crown. So he's looking out of the crown, which is approximately 250 feet above the ground. So we are 250 feet in the air. Okay. He sights a ship coming into the New York harbor and measures the angle of depression at 18 degrees. So we have a ship, okay, coming into the harbor, and he's looking out, and he then looks down at the ship, okay, which is going to be 18 degrees depression. Okay. So it wants us to find the distance from the base of the statue to the ship, to the nearest foot, it says. Okay, so if we have that, then what we're gonna have to do, since we don't have an angle in our triangle, we have 250 and we have X, but we have no angle besides our 90. We have to then take this 18 and put it down here as well, because those are what we call alternate interior angles. Okay, so we have our 18-degree angle now, so we can go ahead and create a, find our answer using trig. So if we're looking at 18, in relationship to 18, 250 is going to be our opposite side, and X is going to be our adjacent. So we're going to go ahead and use tangent here because that deals with opposite and adjacent. So we have the tangent of 18 is equal to opposite over our adjacent side. We are going to go ahead and cross multiply. So we get 250 times 1 is 250. And X times the tangent of 18. So to get X by itself, we're going to go ahead and we need to divide away that tangent of 18. And if we do that to get X by itself on that side, we have to do it on the other side as well. So we end up with 250 over the tangent of 18 equals X. So let's go ahead and let's do that math. So we get 250 divided by the tangent of 18. And that's going to give me 769.4. Okay, my directions say to find the distance from the base of the statue to the ship to the nearest foot. So we're going to go ahead and we're going to round that to the nearest foot, which is going to give us 769 feet. Okay. All right, let's go ahead and let's look at number 8. So it says an engineer is 980 feet from the base of a fountain. So we have a fountain here. I don't really know what kind of fountain we got, but we got a fountain, okay? And it says an engineer is standing 980 feet from that fountain. Okay, the angle of elevation to the top of the column of water is 29.7. So angle of elevation, we're going here to the top of that column of water, is going to be 29.7 degrees. The surveyor's angle measuring device is at the same level as the base of the fountain. So that means that he's measuring from here. Okay, so find the height of the column of water to the nearest 10 feet. So we're trying to find, let's do this in a different color. We are trying to find the height of that water fountain. Okay, so I'm going to pull that triangle out. I have 29.7, 980, and I also have an X here. So again, we're going to be using trig. I need to figure out what sides X and 980 are in comparison to that angle measure. So this is going to be my opposite side because it's across from my 29.7. And then my 980 is going to be my adjacent side. So I'm going to say the tangent of my angle. Since I have opposite and adjacent, I'm going to be using tangent, is equal to X over 980. Okay, and we're going to go ahead and cross multiply. So X times 1 gives me X. And then I'm going to take 980 and multiply it by the tangent of 29.7. So we're going to go ahead and multiply that. We get 980 times the tangent of 29.7, and that gives us 558.9. The directions say to find the height of the column of water to the nearest 10 feet. So what that means is that's either going to make us have 550 feet or it's going to have us have 560 feet. And since this is an 8, that's going to go ahead and round that 5 up to a 6. So we are going to be at 560 feet. Okay, I want to look at one more real quick. I want to look at number 9.
Tammy Talbert, if you are in the building, please report to the main office. Tammy Talbert, please report to the main office.
Sorry for the interruption. So we're going to look at 9. That's going to be it. And so if we're looking at 9, it says a 6-foot tall man is viewing the top of a tree with an angle of elevation of 83 degrees. So if we have our man here, and he is 6 feet tall. Okay, he is viewing a tree. Okay, and he is viewing the top of the tree, and the angle of elevation is 83 degrees. Okay. He is standing 12 feet from the base of the tree. So we are 12 feet away from the tree. Draw a sketch of the situation show a stick figure for the man, which we've done. And it says label the angle of elevation, the height of the man, and the distance the man is standing from the tree. So we've done all of that. The man is 6 feet tall, the angle of elevation is 83 degrees, and he is standing 12 feet from the tree. So it says write and solve an equation to find the height of the tree and then round your answer to the nearest tenth of a foot. So first thing we're going to do is we are going to find sum of the tree by finding that distance x. Okay, so if I pull out that particular triangle, I have x, I have 12, and I have 83. The 6 is not going to be in this triangle. So again, I'm going to have to use trig, so I'm going to figure out what sides I have in relation to this 83. So I have my opposite side x, and I have my adjacent side 12. So that is going to use tangent. I'm going to say the tangent of my angle 83 is equal to opposite over adjacent. We're going to cross multiply, so we're going to get x is equal to 12 times the tangent of 83. And let's go ahead and see what that is. So we get 12 times the tangent of 83. And that gives me 97.7. Okay, now the only issue we have is that is only this distance. We still have that 6 foot, that's how tall the man is. So we need to go ahead and add 6 to that, which is going to give us, oops, plus, nope, that's not what I wanted to do. 97.7, gosh dang it, 97.7 plus, not minus, plus 6. That's going to give us 103.7. Okay, now it says to round our answer to the nearest foot. So if we have that 0.7, that is greater than 5. So we're going to go ahead and round this up to 104 feet. That's how tall our tree is. Okay, and that was numbers 4 through 9.